The new tunnel boring machine for the 2nd Avenue subway in New York weighs 700 tons. It measures 22 feet in diameter and will dig through bedrock and clay under East Harlem, installing precast concrete tunnel lining as it moves, advancing 35 to 40 feet per day. The MTA signed a contract worth nearly $2 billion for this next phase, extending the queue line by 3 new stations. The tunnel boring machine is scheduled for delivery at the start of 2027. It is being manufactured right now in a factory in Schwanau, in the Black Forest region of southwestern Germany, by a privately held family company called Herrenknecht. That same company built the tunnel boring machines for the BART extension under San Jose, the Purple Line subway under Wilshire Boulevard in Los Angeles, the Hampton Roads Bridge Tunnel in Norfolk, Virginia, and dozens more across the country. But nearly every major American tunnel built in the past 2 decades required a machine shipped from a small town in the Black Forest. And only one American tunnel boring machine manufacturer is still competing at scale. If you follow Heavy Infrastructure, subscribe. This story covers every major U.S. tunnel project of the last 20 years and the German factory behind all of them. Martin Herrenknecht founded the company in 1977 in Schwanau, a town of 5,000 people in the Rhine Valley of Baden-Württemberg, southwestern Germany. The headquarters and main manufacturing campus are still there. Nearly 50 years later, the company has never gone public, never merged with a larger industrial group, and never sold a controlling stake to outside investors. It remains family-owned, a structure that has allowed long-horizon investment in engineering development without quarterly earnings pressure. Herrenknecht builds tunnel boring machines from 0.1 meters in diameter for utility crossings up to shields exceeding 19 meters for highway and rail tunnels. The company has completed over 6,200 projects worldwide, spanning metro systems, water supply tunnels, hydropower tunnels, subsea crossings, and road tunnels on every inhabited continent. By project count, no other tunnel boring machine manufacturer on the planet comes close. Every machine follows the same cycle: designed, fabricated, and fully assembled in Schwanau, tested under load on factory stands, disassembled into shipping sections, and transported 20 kilometers to the Kiel port on the Rhine. Shipped by ocean freighter to the destination country, reassembled on site in a launch shaft by a crew that can spend 6 months putting the machine back together before a single foot of tunnel gets bored. The 2nd Avenue subway Phase 2 is one of the most closely watched infrastructure projects in America right now. The MTA is extending the queue line from 96th Street into East Harlem, adding stations at 106th, 116th, and 125th Street. The first phase took 9 years of active construction and opened in January 2017 with 3 stations. The Herrenknecht machine for Phase 2 will bore twin tunnels through Manhattan schist, one of the hard tunneling environments in the world, the same ancient metamorphic rock that gives Manhattan the geological foundation to support 80-story skyscrapers. The 22-foot cutter head will grind through that rock face while hydraulic rams push the entire 700-ton assembly forward. Behind the cutter head, the trailing gear stretches hundreds of feet through the finished tunnel, housing the crew, the muck conveyor, the segment erector that installs concrete tunnel rings, and the ventilation systems. The total project cost is estimated at $6 to $7 billion, making it one of the most expensive per mile subway extensions ever built. The tunnel boring machine from Schwanau is the centerpiece. 3,000 miles west, the West Side Purple Line extension in Los Angeles runs 9 miles under Wilshire Boulevard from Koreatown through the Miracle Mile through Beverly Hills and out to the VA Medical Center near the 405 freeway. It is the largest subway construction project in the city's history. The project was split into 3 sections, and everyone used Herrenknecht earth pressure balance machines shipped from Germany. Section 1 covered 3.92 miles for $1.6 billion. Section 2 covered 2.6 miles for $1.37 billion. Section 3 covered 2.6 miles for $410 million. The machines were designed specifically for the mixed-face geology under Wilshire Boulevard, where the tunnel passes through tar sands, methane gas pockets near the La Brea tar pits geological formation, and shifting groundwater pressures that change block by block along the alignment. Each machine maintains a pressurized chamber of excavated soil at the cutter face to prevent ground collapse and surface settlement, a non-negotiable requirement when boring directly beneath one of the most expensive commercial corridors in Los Angeles. Every foot of that 9-mile tunnel was bored by German iron. On the opposite coast, the Hampton Roads Bridge Tunnel expansion in Norfolk, Virginia, is the largest highway construction project in the state's history at $3.8 billion. The project involves boring twin tunnels under Hampton Roads Harbor to expand capacity on Interstate 64, one of the most congested bottlenecks on the entire East Coast corridor. The Heron Connect variable density shield measures 46 feet in diameter, making it the second largest tunnel boring machine ever used in the United States. Unlike a standard earth pressure balance machine that operates in a single mode, the variable density shield can switch between earth pressure balance mode and slurry mode depending on what geology it encounters at the tunnel face. That adaptability is critical for a harbor crossing that passes through soft marine sediments, sand layers, and clay formations beneath the harbor floor, where conditions can change within a single advanced cycle. The alignment runs approximately 50 feet deeper than the existing Hampton Roads tunnels, which were built using immersed tube segments lowered into a dredged trench in the 1950s and the 1970s. This is only the fourth tunnel boring machine bored highway tunnel in U.S. history, after the Port of Miami Tunnel in Florida, the Seattle SR 99 Alaskan Way Tunnel in Washington, and the parallel Thimble Shoal Tunnel on the Chesapeake Bay Bridge Tunnel in Virginia. Highway diameter tunnel boring remains exceptionally rare in America. Subscribe if you want more breakdowns on who actually builds American infrastructure. I cover this every week. The BART Silicon Valley Phase 2 in San Jose will push Bay Area rapid transit 5 miles underground with 3 new stations at 28th Street, downtown San Jose, and Diridon Station. The tunnel boring machine was ordered from Heron Connect in 2023 at a cost of approximately $76 million. When assembled, it will be the third largest tunnel boring machine ever built on the planet, with a cutter head approximately 54 feet in diameter. 18 months of manufacturing at the Schwanow factory, shipped in sections from the Cal port across the Atlantic, through the Panama Canal, and up the Pacific coast to California. 6 months of reassembly at the West Portal in San Jose before boring can begin. 3 to 4 years to complete the 5-mile drive at 30 to 40 feet per day through the clay, silt, sand, and gravel of the Santa Clara Valley floor, with the tunnel alignment passing directly beneath highway overpasses, commercial buildings, and residential neighborhoods. California alone has an extraordinary concentration of Heron Connect machines, either active or recently completed within the same state. The Silicon Valley Clean Water Project in Redwood City used a 16-foot, 900-ton Heron Connect machine to bore 2.4 miles of wastewater tunnel under Redwood Shores Parkway, an $18.2 million machine within a $495 million project. The Clearwater Project in Los Angeles County, a $630 million tunnel run by the LA County Sanitation Districts, replaced wastewater pipes installed in 1937 and 1958, connecting the Joint Water Pollution Control Plant in Carson to the ocean off San Pedro's Royal Palms Beach. The Arrowhead Water Tunnel near the San Bernardino Mountains used 2 Heron Connect single shield machines, custom built for high groundwater pressure and decomposed granitic rock in close proximity to the San Andreas Fault, one of the most challenging geological environments for tunnel boring anywhere in North America. All German machines, all shipped from the same factory campus in the Black Forest. There is one notable exception to Heron Connect's dominance in recent American megatunnels, and it proves the pattern rather than breaking it. Seattle's SR 99 Alaskan Way Tunnel was bored by a machine named Bertha, the largest tunnel boring machine in the world at the time of its launch. Bertha measured 57.5 feet in diameter, weighed between 6,700 and 8,000 short tons, and created a 2-mile highway tunnel under downtown Seattle, completing the bore on April 4th, 2017. But Bertha was not built by Heron Connect. Bertha was built by Hitachi Zosen in Osaka, Japan. The biggest American tunnel project of the 2010s went to Japan, not Germany, and not America. The American manufacturer does exist. The Robbins Company, founded in 1952 by James S. Robbins, is headquartered in Solon, Ohio. Robbins is the oldest American tunnel boring machine manufacturer and is credited with developing the modern TBM concept. In hard rock applications where the geology is predictable solid stone, Robbins competes with any manufacturer on the planet. But the largest diameter urban tunnels in America today involve variable ground, mixed face geology, active water tables, and surface settlement risk beneath dense cities. That combination is where Heron Connect has captured nearly every major contract. The 2nd Avenue Subway, the Purple Line, the BART extension, the Hampton Roads Tunnel. Robbins could have bid on each. None of them went to Solon, Ohio. Understanding why requires understanding what these machines actually do inside the earth. The front of a tunnel boring machine is the cutter head, a massive rotating disc studded with cutting tools that grind against the tunnel face. In hard rock, disc cutters fracture stone through concentrated rolling pressure. In soft ground, scraper blades and mixing bars chew through clay, silt, and sand. Behind the cutter head sits the shield, a cylindrical steel shell that prevents the freshly excavated opening from collapsing. Earth pressure balance machines, the type Heron Connect builds for most American urban projects, use the excavated soil itself as a pressurized medium. The soil fills a sealed chamber behind the cutter head, and screw conveyors regulate the outflow to maintain face pressure that counterbalances groundwater and earth pressure from the outside. That prevents blowouts and surface sinkholes above the tunnel. As the machine advances, a segment erector inside the shield places precast concrete ring segments into position. Each complete ring forms a watertight circle, and the finish lining goes in immediately behind the advancing shield. Behind that, the trailing gear stretches 300 feet or more through the completed tunnel, carrying the crew workspace, electrical systems, ventilation, muck conveyors, and monitoring equipment. The entire assembly is a mobile underground factory, advancing one ring at a time, 24 hours a day. Building a machine that manages all of this simultaneously across variable geology at 46 or 54 feet in diameter is where Heron Connect's 5 decades of accumulated engineering separate them from every competitor. The Infrastructure Investment and Jobs Act authorized over $550 billion in new federal infrastructure spending. That legislation means more tunnel projects are coming to the United States over the next decade. More subway extensions in cities that have deferred them for generations. More highway crossings beneath harbors and rivers where surface bridges have hit capacity. More water and wastewater conveyance tunnels, replacing pipes that have been underground since the Great Depression. The machines that bore those tunnels will be designed in Schwanau, manufactured in Schwanau, shipped from Kehl, and reassembled on American soil by American tunnel crews who operate German iron underground 50 feet beneath cities that stop building the machines themselves. Subscribe for more on heavy equipment and the companies that actually move dirt.